Hi everyone, I'll be talking about capacity planning. We're talking about introduction, measures of capacity, estimating future capacity needs, factors influencing capacity, and aggregate planning. Introduction. The design of production systems involves planning for inputs, conversion process, and outputs of production operations. The effective management of capacity is the most important responsibility of a production manager. Its objective is to match the level of operation to the level of demand. Hence, after demand forecasting comes capacity planning. Capacity is the rate of productive capability of a facility. Production managers are therefore concerned about capacity for the following reasons. One, sufficient capacity is required to meet customers' demand in time. It affects the cost efficiency of operation. Capacity affects the scheduling system, and capacity requires investment. Measures of capacity. Capacities have different ways of measuring it. We have the design capacity, which is the capacity of a facility as engineered when it is manufactured. For example, the design capacity of a cement plant can be 100 tons per day, or the design capacity of a sugar factory can be 150 tons of sugarcane crushing per day. System capacity. System capacity is the maximum output of the specific product or product mix the system of workers and machine is capable of producing as an integrated whole. The system capacity is always less than the design capacity, or at most equal to the design capacity because of the limitations of product mix, quality specification, breakdowns, and so on. License capacity. License capacity is a capacity licensed by the various regulatory agencies or government authorities. This is the limitation on the output exercised by the government. For instance, OPEC that regulates the quantities of barrels of crude oil each country can produce. Rated capacity, it is the one based on the highest production rate established by actual trials. Estimating future capacity needs. Capacity requirements can be evaluated from two perspectives: the long-term capacity strategies and short-term capacity strategies. The long-term capacity strategies. These are more difficult to determine because future demands and technologies are uncertain. Forecasting, for instance, for 5 or 10 years into the future is risky and difficult because companies' products today may not be existing in the future. Long-term capacity planning is concerned with accommodating major changes that affect the overall level of the output in the long term, that is more than 1 year. Marketing environmental assessment and implementing a long-term capacity plan is in a systematic manner are a major responsibility of management. In the short-term capacity strategy, managers often use forecasts of products to estimate the short-term workload the facility must handle. Managers looking ahead up to 12 months anticipate output requirements for different products. For short-term periods of up to 1 year, fundamental capacity is fixed. Major facilities will not be changed. Therefore, managers often use demand forecast to estimate short-term workloads that the facility must handle. Factors influencing capacity. The first is the forecast of demand. Demand forecast influences capacity plan in a significant way. It is very difficult to forecast the demand with accuracy as demand changes significantly with product life cycle and number of products. Products with long life cycle usually exhibit steady demand growth compared to ones with shorter life cycle. Thus, accuracy of forecast influences the capacity planning. Second factor is the plant and labor efficiency. It is difficult to attain 100% efficiency of plant and equipment. The efficiency is less than 100% because of the enforced idle time due to machine breakdown, delays due to scheduling, and other reasons. Thus, plant and labor efficiency are very much essential to arrive at realistic capacity planning. Thirdly, subcontracting. Subcontracting refers to offloading some of the job to outside vendors, outsourcing the work, thus hiring the capacity to meet the requirements of the organization. A careful analysis as to whether to make or to buy should be done, an economic comparison made before taking such a decision. Fourth, multiple shift operation. Multiple shifts are going to enhance the firm's capacity utilization, but especially in the third shift, the rejection rate is higher. So it is highly recommended to have multiple shifts if demands are high. Management policy, which is the fifth one, also affects capacity planning. Management policy with regards to subcontracting, multiplicity of shifts, which workstations or departments to run for third shift, machine replacement policy, etc., all affect the capacity planning. Aggregate planning. Aggregate planning is the intermediate term planning decision. It is the planning of the quantity and timing of output over the intermediate time horizon of 3 months to 1 year, and it seeks the best combination to minimize costs. There are various ways and strategies to do the aggregate planning. The first is to vary the size of the workforce, to vary the hours worked, to vary the inventory level, or to subcontract the work. An example here shows how this aggregate planning is done. The demand forecast for a product for 6 months is shown. Each unit requires 10 man-hour and labor cost is $6 per hour regular time and $9 per hour overtime. The total cost per unit is estimated to be $200 and can be subcontracted at $208 per unit. Currently, there are 220 workers employed, and hiring and training costs for additional workers are $300 per person, where layoff costs are $400 per person. Company policies is to retain a safety stock equal to 20% of the monthly forecast, and each month's safety stock becomes the beginning inventory for the next month. There are currently 50 units in stock, carried at the cost of $2 per month. Stock out costs is $20 per month. The table here, we can see the forecasted demand for January to June, the work days for January to June, and the workers' hours per day for January to June. The workers' hours is gotten from multiplying the work days by 8, which is the work hours per day. 3 plans are proposed. The first plan, A, is to vary the work size to accommodate the demand. Plan B, maintain a constant workforce of 20 and use overtime and idle time to meet the demand. And Plan C, maintain a constant workforce of 20 and build inventory or incur stock out costs. As we know, the firm's beginning inventory January is 50 units. Now we compare the 3 costs and find out the best plan. Solution: first, we determine the adjusted production requirement, which will include a safety stock of 20% of the next month's forecast. Then for January, we have the inventory beginning with 50 units. So subsequently, each month's production requirement will reflect the sum of the forecasted demand plus the safety stock minus the beginning inventory, which is 20% of the forecast of the previous month. So here is the production requirements calculated. In the first column, we have the forecasted demand. In the second column, we have the third column, we have the cumulative demand, which is 500 plus 200, you get 800. Safety stock of 20% of the forecast, that is 20% of 300, we get 600. Safety stock for February is 20% of 500, we get 100. Safety stock of March is 20% of 400, giving 80, and so on and so forth. And the beginning inventory for each month is the safety stock of the previous month. Already we have a safety stock for January, which is 50, given in the question. So the beginning inventory for February will be 60, which is the safety stock of January. Beginning inventory for 100 for March 100, which is the safety stock of February, and so on. Production requirements now will become the sum of the forecast and the safety stock minus less the beginning inventory. So please correct that. This is minus BE. It's 300 plus 60 minus 50, which is 310. For February, 540 until June, which is 320.